So, good evening, everyone. Welcome to the online discussion of water and wastewater treatment course that is being taken by Professor Manu Prakash from IIT Roorkee. My name is Maniratnam Prakash, and I am here. I am from IIT Kanpur, and I will be conducting this online session. So this is a schedule that we meet every Tuesday from 7 p.m. to 9 p.m. and the link is being shared by you, and the recording of this session is being uploaded on this YouTube channel. So you can, if you have any kind of doubt, you can access that video. So coming to the big six, we have there was a discussion about these five topics. So phosphorus removal, there it was in two part one was discussed in big five, and the remaining portion of phosphorus removal was discussed in big six. Then there is some discussion about attached growth, how the attached growth and its different kind. Then there was some kind discussion on disinfection, then a special discussion on chlorination disinfection, and the problem which is faced by this disinfection by production of this bioproduct that is known as DPD, and several things. So in this session there are total 10 questions and some concept related to it. So I will be going one by one. If you have any kind of doubt, you can raise your hand in between the discussion and you can ask me. And during discussion, if some like there is problem of net, because last week there was some problem due to net problem, so please rejoin using same link. I will be starting I will be making all the correction. I will try to rejoin as soon as possible. So if you face that problem, please rejoin again using the same link. The session will be from 7 p.m. to 9 p.m. So question will be related to these things only, these topics only, and you can expect this type of question in your final assessment or the assessment which is going currently on weekly basis. So the first question is based on the phosphorus removal. So the question is, which of the following is not advantage? So it is asking not advantage of biological phosphorus removal over chemical precipitation method. So we know that if you have gone through the online lecture, you must be aware that phosphorus removal can be by two method, that is biological method. In biological, they use some kind of microorganism, microbes that degrade phosphorus with time, and that phosphorus is being removed. And the second method is use of chemical precipitation. Some kind of chemical is added in the wastewater. Some chemical is added in wastewater, and that chemical forms some bond or precipitate with some compound with phosphorus, and they precipitate on the system. So if we go through the options are low chemical consumption, low sludge production, high phosphorus removal efficiency, and high chemical composition, high chemical consumption. So I will be discussing each and every option one by one, and based on the discussion I will be concluding my final answer. So the first option was the low chemical consumption. So if we read out, the biological phosphorus removal typically requires low chemical consumption compared to the chemical precipitation. So see what happened, that we know that in biological removal method we use some kind of microbes, and that somehow we do not add directly some kind of chemical. So what they say, that a little amount of chemical is being added. So hence this statement is correct, and they are, remember the question is not advantage. So we have to take out the option which is not advantage over biological first use of biological removal over chemical precipitation. So read out the question in a proper way, and based on the discussion I will be concluding the final answer. So if we look at the low chemical consumption, the biological phosphorus removal typically requires lower chemical consumption compared to the chemical precipitation method. In biological process, microorganisms are utilized to metabolize phosphorus, reducing the need of additional chemicals. This leads to cost saving, environmental benefits due to decreased chemical usage. So this is a kind of advantage of biological treatment, because uh, uh, we are not supplying any kind of chemicals, because chemical requires some kind of additional cost. Microbes are very cheaply available in the market. If you go to these organic things, you can get microbes that can be used. A special type of microbes are used, but still those are very cheap as compared to some of the chemicals. For example, in phosphorus removal, alum sometimes alum is used. So those are very costly things. Some people also use magnesium to precipitate out. Magnesium, no, sorry, I don't know about this magnesium. Calcium is used for precipitation of phosphate. So they add calcium, and the calcium phosphate combine, they form some kind of element known as bracite. So that is another thing. But addition of calcium is very costly thing. So this is a kind of advantage. Um, this is a kind of advantage to miss the low chemical consumption is a advantage of biological treatment. Okay. The second is low sludge production. The biological phosphorus removal often results in a lower sludge production chemical to chemical precipitation method. So remember, what's happening that when we are using chemicals, that will form some kind of precipitate with the phosphorus present in the system, and that will surely precipitate on, and it will form some kind of solid, and that solid will get settled at the bottom of the your tank sediments, any kind of tank where this activity is happening, and that will form a kind of sludge in the system. But in biological process, what will happen that microorganism assimilate phosphorus into their biomass, which can be subsequently be removed through the settling or filtration process. So what happened that we know that for any micro phosphorus is needed. Assimilation means they are consuming the phosphorus. We know that nitrogen and phosphorus are main. If you have uh, watch the previous big question there, previous big discussion, there was one question related to this: what is the main ingredient, main biomass component of biomass component of microbes? The answer was nitrogen and phosphorus. So now imagine in a wastewater that has some kind of phosphorus, you are adding some microbes. So that microbes, that will be good for microbes, and that will also good for me, because that microbes will help in the phosphorus removal. And what will happen that once those microbes has eaten that phosphorus, yeah, consume that phosphorus in, their mass will be very less, so that can be removed by simple filtration unit or settling system. This can result in reduced sludge generation, which lower disposal cost and minimize the environmental impact associated with the sludge handling and disposal. So you can just simply imagine chemical there. You are seeing some particles which is forming, which is getting settled. So obviously there will be some additional expenditure to remove that, and there is and on other hand, using biological method, you can just simply remove by some slow process like filtration and all these things. So there is no much expenditure you have to do on your treatment method. Okay. So the coming to the C option, high phosphorus removal efficiency. Biological phosphorus removal process can be achieved high level of phosphorus removal efficiency. Microorganism, particularly certain type of bacteria known as phosphorus accumulating organism, can accumulate phosphorus within their cells under a specific condition. This allow for effective removal of phosphorus from water and after exceeding the regulatory requirement. Okay. So what it's saying that this is high phosphorus removal efficiency. So remember, when we are talking about chemical precipitation, remember there is some specific condition like pH of the water should be this much, because for formation of some kind of, suppose this phosphate is reacting with some kind of chemicals that you have added, say calcium, so it requires certain pH of the system. If the pH is exceeding that or below that, there is a possibility that phosphorus won't be removed from the system. But this is not case with the biological treatment. You have added some microbes in the system, it will react. Obviously it requires some external condition like pH should be sufficient, there should be oxygen and all these things. But But that can be regulated in the system. Now, so suppose for chemical precipitation, what is happening that a certain pH range is required now, and your water pH is not in that range. So you have to adjust that pH, and that will cost additional thing. So, and now imagine that pH is not as per required for the precipitation of that phosphate from the system. So what will happen that some of the phosphate will be removed from the system, and some of the phosphate cannot be removed from the system. Okay. So this biological is a biological removal efficiency will give high miss this biological phosphorus removal will give high efficiency. Sorry, the second is, this sensor can be this can be compared with the first option was that low chemical consumption. So chemical consumption, obviously it low chemical was required when we are using microbes, or you can say no chemicals is also required, only we add some amount of chemicals to adjust the there is something called lag phase. If you look at the biomass concentration with time, how microbes, there's some called growth phase and all these thing. Sorry, growth phase, and so initially there is something called lag phase. So what happened that microbes need some external condition like pH not temperature and all these things to adjust himself in that condition, so that it can degrade the organic matter present in the system. So a little amount of chemical is added. So or sometimes what happens that condition is favorable for the microbe to grow, so there might be such case that no chemical is required. So D option is saying that high chemical consumption. So this will be our answer, because all these three option which we discussed was advantage to the biological treatment, like low chemical, high efficiency, and all these things, and low sludge. But when we say high consumption, this statement you can say contrast the advantage of biological means biological phosphorus removal. Unlike biological process, a chemical precipitation method may require addition of chemicals such as metal, alum, or ferric chloride to precipitate phosphorus as insoluble compound, which then we remove from the wastewater. You can see that in chemicals we add chemicals. That is the case. That's all. You should remember this. So the answer of this question will be, correct option will be D. Okay, I hope the first question was very easy. It was simple. You can expect this kind of question in your assessment. So I will be coming to the second question. This breakdown chlorination. So see, I am just discussing. I'm not going in the detail. What is when I was discussing this question, I was just discussing some basic things. That this, if you want to go in more technical things like which chemicals are used, which microbes are used, you must read that. You must watch the video which has been given to you, because before without watching those video, there is no meaning of this discussion, because I will be just touching the surface, some basic concept like this thing is happening, that thing is happening. But if you want to go in the deep, you have to watch those videos, or the instructor, the video which has been taken by the instructor. Okay. So the steps involved, the second question is the steps involved in chlorination, breakpoint chlorination. So first you have to know that what is this breakpoint chlorination. I will be discussing in some details, but um, I will be just discussing in the details. So remember, this is chlorination curve. So what is this chlorination? Chlorination which we use in disinfection, because after treatment, what happened that we have removed all the sludge, suspended particles, all the microorganism, but still there are some pathogens removed in the system, which is there in water. It's not even visual by our eyes. Okay. So to remove that microbes, which is very harmful for if that water is being discharged in the river or being used for drinking purpose. So what will happen that that will directly or indirectly affect the user which is using that water. So what happened that we use so there are several disinfection method like chlorination, ozone, UV, use of iodine tablet and all these things. But the most what we cost effective method is use of chlorine. So we add chlorine in the system in some form, say in the form of NaOCl and yeah HOCl, in any kind of it can be add, so that that helps in the further just in what form we add chlorine, that's another thing. So we add chlorine in some form, it will dissociate and it will kill all the microbes or sorry not microbes, pathogen which is present in the system. And how this chlorine kill those microbes, you have to go to the lectures or to some referred book where you will see how this chlorine is very oxidizing in nature. So it oxidizes the cell of the pathogens, yeah, microbes present in the system, and it kills the harmful bacteria present in the water. So there are different phases, like so in graph you can see there are four phases of this chlorination process, and this is known as chlorination curve. Okay, the first is instantaneous chlorine demand. So what happened that as soon as you add chlorine, so that the pathogens, yeah, bacteria present in the system can be in different form. So one of the form is like in form of organic carbon. So what will happen that as soon as you add the chlorine in the system, uh, yeah, that chlorine will oxidize that organic matter, and that will fulfill the our instantaneous demand. So suppose sorry, actually when someone leave I just got distracted, I don't know why they are leaving. Okay, that's another thing. So what I was saying that the first income instantaneous demand. We know that in our system there can be many things. So if organic carbon is present, so first that is very means what will happen that that chlorine will oxidize those organic matter present in the system, and it will fulfill your instantaneous demand. Yes. Instantaneous demand. So now what will happen that after instantaneous demand, now suppose imagine that your water don't have to imagine ammonia is already present in the system. So what will happen that after that ammonia present in the system will start reacting with chlorine, and it will react as follows. So remember, this ammonia can be in two form, that is in ammonium if the pH of the system is less than 9.5, which is generally the pH of the water. Any wastewater pH is around 6 to 9 only. So what will happen that in that form the ammonia will be in the form of ammonium, and this ammonium will react with the chlorine. And now remember, chlorine is not in the form of Cl2 in the system, it will be in the form of HOCl or OCl minus depending on the pH of the system. So around pH less than 9.5, or there is some also range of pK value of HOCl. So what will happen that this ammonium will react with OCl minus, and it will form monochlorine. This is known as monochloroamine. Okay, because single ammonia is reacting with 1 mole of chlorine. So that is known as monochloroamine. So after that, what will happen that this mono will react with further ammonia chlorine present in the system, and it will form dichloroamine, and this dichloroamine will further react and it will form a trichloroamine. So what they are doing that they are forming some kind of combined what do we call combined chlorine residue. Okay, so as this residue are present only due to chlorine, now what happened that this chlorine is not in the form of chlorine now, they are in the form of they are in the form of they are in the form of amine, that is they are reacting with ammonia. That's why they are known as monochloroamine या dichloroamine या trichloroamine. Okay now. So as these residue are present only due to chloramine but not due to HOCl or Cl minus, hence they are referred as combined chlorine residue. Okay. So the see first phase was instantaneous phase. Second phase is due to reaction with, now what is happening that I am adding ammonia, sorry, I am adding chlorine, so they are forming some kind of residue, combined Cr is known as combined chlorine residue. They are forming some kind of residue with the help of ammonia present in the system. Now imagine that you are adding, you are after this formation you are adding more ammonia in, more chlorine in the system. So if we add more chlorine, it will start reacting with ammonia and other chloramines. So now what happened that all these chloramines has already formed. So if you and this point has reached, means it has reached a maximum point. So after that, if you are still adding chlorine in the system, so what will happen that it will start reacting with the ammonium present in the system and all the chloramines that has been formed in the system, and it will again what will do that it will convert this nitrogen into N2 gas, and that will escape in the system, other chloramines. And what will happen that this point so now what will happen that the concentration of this Cr, combined residual, because what is happening that I am still adding, I am adding more chlorine to the system. So all the chloramine that was formed during this time, or that is during this time, will start reacting with the chlorine that is being applied to the system, and the concentration of chloramine, yeah, the value of this Cr will start decreasing. Okay. So that is, this is what here I have written. Hence it will start reacting with chloramines. Hence the combined chlorine residue are being destroyed on addition of more chlorine. More addition of chlorine will decrease the Cr, and we will come to the point where Cr will be the minimum. So what will happen that at some point all the chloramine which was there in the system has been exhausted. So it will reach a point known as this breakpoint chlorination. So remember, initially there was instantaneous chlorine demand, then there was formation of chloramines, then there was destruction of chloramines, then we have reached a minimum Cr value. This is called a minimum Cr value. Now nothing is present in the system. All the ammonia has been escaped in the form of N2. All the organic matter which is there has uh, uh, which was there has escaped from the system. So now what will happen that we have reached one breakpoint. We have reached a minimum point, and that minimum point is known as breakpoint of chlorination. Ammonia has, remember, the ammonia has oxidized, and this point is known as breakpoint chlorination. Okay. So after this, if we add chlorine, it remains as chlorine, and this is known as free chlorine residue. So now after that, all the things, whatever the purpose of chlorine was there in the system has been completed. Okay. So has been completed. So there is no need of additional chlorine. So what will happen that whatever chlorine I will add, it will be referred as free residual. Okay. And remember there is a limit that how much chlorine, residual chlorine should be in the system, and that is 0.2 milligram per liter. So what will happen that now during disinfection, I have made sure that all the microbes, all the pathogens present in the system is being destroyed, all the ammonia present in the system is being destroyed. But what will happen that once it is open to the some channel, yeah, it is being provided for the drinking purpose, there might be some external pathogen might come in the your water, so that pathogen has to be killed. So we add some extra chlorine in the our water, so that future contamination or future infection can be done. So this is the advantage to prevent future contamination in the water, treated water. So the our question was, so you have already known this, known four steps. and you have to identify a correct sequence. So first option was destruction of chloramines, so it is third step. Okay. hmm Sorry, the destruction of chlorine by readily available compound. So this is first destruction of chlorine by readily reducing compound. Formation of chloroorganics and chloramines. So this is second step, this is first step, and this is third step, and this is last step. Okay. So the option will be what will be option third 3 2 1 4. 3, that is destruction of chlorine by readily reducing compound. uh, just 1 minute. Actually, none of the option is correct. I have what option B is. I've said there is. I might have written wrongly. 3 2. No, sorry, I have written correctly. The first destruction, then formation of chloramines, then destruction of chloramines, then formation of this free chlorine. Okay, so the correct answer will be this B 3214. Okay, so remember there are two things from this point to this point. This is correct. From this point to this point, it is known as demand. Okay, na demand. Like how much nitrogen is removed, how much chlorine is needed for fulfilling or destroying our pathogen, and from here to here it is known as dosage. There is two concepts which is generally asked in interview or in any exam. What is demand and dosage? Demand is just to fulfill the uh, demand is just to make sure that all the bacteria, all the pathogens present in the system are being killed. But dosage is to make sure that all the all the pathogens are killed, and to prevent the what do we call, prevent the further future contamination. Okay. So remember, initially I have said this is very cost effective. The reason to say this cost effective is that when we are using ozone or ultraviolet ray, so what they are doing, that ozone is ozone, what will happen, that it won't prevent from the future contamination or further contamination which might be externally coming from somewhere, or in same is with the UV. But the concept in all those three other disinfection method is that I have to kill the pathogens. Okay. So this was let me see, there are several things associated. The most important part is that this how this OCL and HOCl kills microbes. There are some numerical question also. You can find these numerical questions in gate previous year questions. There are several plenty of numerical question where they actually calculate how much chlorine should be added in the form of some chemicals. Okay, so I will suggest you to go through the some standard books or previous year gate questions. Okay. So see, uh, this is another type of disinfection method, that is uh, use of UV rays, ultraviolet rays. The mechanism of UV disinfection is that it disinfect by directly damaging the nuclei acid of the pathogens. So you have to identify this is either true or false. So see, remember obviously this is correct answer. True. So uh, they miss this is all the disinfection method which is present in the which is done in the treatment method work by this method only, by damaging nuclei acid of the pathogens. First, what will happen, that they will disintegrate, they will destroy the cell wall of the pathogens, outer cell membrane of the pathogens, and then finally they will attack on the nuclei of the pathogens. Okay. The statement is true. The UV disinfection works on the damaging nucleic acid, that is DNA or RNA of the pathogens such as bacteria, viruses, and other microorganisms. Specifically, UV radiation at certain wavelength, typically around 254, penetrates the cell wall of the microorganism and disrupts the molecular bond of within the DNA or RNA. This damage prevents the microorganism for sorry, there is this is a problem of IIT Kanpur. Dogs are everywhere. This damage prevents the microorganism from replicating and functioning properly, ultimately leading to its activation or death. So this statement is true. I won't be giving too much time on this question. Okay. Hmm. So this is another question. What is the main purpose of using chloramines in the water treatment? Okay. So there are four options, and if you have gone through this question, you can answer this question. So I will just asking from you guys that if you can answer. There, how many people are there? So there are two people. Hmm. So try to answer this question, and after that I will be discussing it. So 2 minutes time, 1 minute time. Sorry, 1 minute, no, 30 seconds. What is the main purpose? The first option is to remove iron and manganese, to provide a longer lasting residual disinfectant, to remove phosphorus, to remove sulfur, to remove bacteria and viruses. So I think this is very clear to you. Actually, this is sorry, this is multiple correct. What R means? I'm just correcting it. Sorry for the inconvenience. What R? Actually, so what main purpose is? Sorry, B and E. Actually, sorry. My mistake. They are asking for chloramines. Okay, now they are not asking for chlorine. Okay, so question is correct. My mistake. Actually, if you are saying B and E, that is also correct. But currently, this longer lasting residual disinfection is only due to chlorine. Remember, all the chloramines are being destroyed herein only. All the chloramines. So uh, this chlorine is for long lasting, like after some when water is discharged. Okay, now so sorry from my side. I just misinterpreted interpreted the question in wrong way. Okay, so the chloramines are up to this level, and at this level, what happened that this chloramines, with the help of chlorine, they destroy our bacteria. Okay, so the question is correct that what is the main purpose of the using chloramines in the system. Okay, the primary function of the chloramine is to provide longer lasting residual. I think I have said something wrong. To provide a longer lasting residual disinfectant. Hmm. So just let me say chloramines are the group of compounds from the reaction of ammonia with the chlorine. This is well known. They are used in water treatment primarily for their ability to provide a longer lasting residual disinfectant compared to the free chlorine. So remember, so what happened that this free chlorine, what will happen that they won't be they are very unstable in the system. So what will happen that they will escape from the water in the form of chlorine gas. So it is said that these are very unstable. So we need something which is very stable, and that will also kill our bacteria or our pathogens present in the system. So these chloramines make sure that all the pathogens present in the system are being killed at for a given particular time, because we cannot be dependent upon the chlorine. These residual disinfectants help in the maintain water quality and prevent microbial regrowth as the water levels through the distribution system. Additionally, chloramines can be reduced by the formation of DPDs compared to the free chlorine, making them advantageous in the terms of water quality and the safety. Okay. So initially I was saying something wrong. So after this discussion, I hope this is clear to you that how this chloramines works. So it's all depend upon. See, my main purpose is to kill my pathogens. Now we cannot be dependent upon the chlorine because those are very unstable in the water. They can escape in the system, or they can escape from the system. So it's better to use something which is long lasting and which is stable also. The correct answer will be B. So though I hope this is clear to you. Okay. So another question is related to trickling filter. So what is this trickling filter? So this trickling filter is something which we called as attached grow. So in previous class we were discussing about activated sludge process. So in activated sludge process, what happened that there is some this a tank kind of system in this wastewater is there, and some microbes will be there, and that will be degrading our organic matter. So this was a suspended growth because there was no this bacteria, this microbes were suspended in the system. So now we are discussing about the trickling filter, which where what will happen that we need a there will be a media. Imagine this is a media, and this media may be of plastic, glass, or any kind of a special thing, and on this media there will be a layer of microbes surrounding this media, and water containing organic matter will pass through it in the presence of oxygen or in presence of air. And that what will happen that this attached microorganism will degrade the organic matter present in the system, and in this way the secondary treatment or biological treatment of the um, wastewater is done. So this is main concept of that in once is suspended, that is freely available, freely roaming here and there, and in second case the bacteria is attached on some kind of media. Okay. So they are select the correct options. So this is multiple correct answer, that is select the correct options regarding advantages of trickling filter. A trickling filter can withstand shocks and loading. Nitrogen removal efficiency is very high. There is no order and fly nuisance and simpler operation. Okay. So first, sorry. First, I will discuss about this. What is this? I will just little bit discuss about this trickling filter. So the attached, this is the concept of attached growth. The attached growth concept is based on the observation that biomass prefers to attach itself on the inert surface. So if this is a plastic, so this will be inert. On inert, so microbes have the tendency to attach themselves on something. So we will be using only those microbes which has this kind of efficiency, and we are using, see, which kind of microbes has to be used in which system depend upon the characteristics of, if suppose that suppose if I take out these microbes and put in this tank, it won't survive here. Similarly, if some microbes works in the condition which where suspension is required, so it won't be working on this system. So in both cases we require some different kind of microbes. Okay. Hence, if inert media is provided inside the reactor, biomass will grow attached to this media. Such biomass will not be able to escape from the reactor easily, hence it is attached. Thus, high biomass concentration can be maintained inside the reactor. Okay. So I hope this is clear to you with the discussion. So remember how this trickling filter works. So this is my media surface. This is my media. Okay. This is my media, and here on this there is this thing biomass layer. Okay, this red thing is biomass layer, and this is inert media. Remember, this can be of either plastic and some kind of thing. Sorry. And what will happen that we are trickling the sewage. Trickling means, I hope everyone is clear with the term trickling. We are passing very slowly. Trickling means something, when we trickle means it pass the sewage passes slowly over this layer of biomass. Okay. So what will happen that as this sewage will trickle over this biomass will degrade the organic matter present in the system. So this is a outlook of this how trickling filter generally work in our suspension, in our, what do we call, in wastewater treatment. So this is a trickling filter. From here the water will go in the suspended secondary sedimentation tank, and here the sludge will be collected. So after, what will happen that this media, I will be showing one clear image in upcoming question how this trickling filters usually look. Okay, but this is the main concept of this trickling filter. So there will be a biomass layer, there will be a media, on that there will be a biomass layer, and the sewage will trickle over that biomass. Okay. So sorry, in this question, so this is, remember, this is a trickling filter. This is a, I have taken this from internet, and this is a flow diagram of how this trickling filter look like. So remember, these all things all are very what do we call, media, where this media is present throughout the system. Water is being sprinkled from here. Okay, so remember, this is a sprinkle system, and here there will be some kind of this media, either plastic or either glass, or it can be in any kind of, I am just showing in a plastic mode. And it can be of different type, and these will be fitted here, and on this media bacteria will be there, and water sewage will be coming from this outside, sorry, from this sprinkler, and it will trickle over the surface of this media, and that when it will be trickling, the biomass present in that over that plastic media will degrade our organic matter. The sewage must trickle, that is air must be present inside the filter at all the times. Air supply through the conductivity current or the fan. Okay, so TF is trickling fan. Okay, na, in the, sorry, through in that trickling filter. So air should be, so remember, here there is two things. Apart from the sewage, we are also providing air, because what will happen that now you are not providing air, so there might be a condition of aerobic condition. Okay, so and it might happen that that bacteria may not work in the anaerobic, sorry, in absence of air, it might convert into anaerobic condition there, because this air is providing free oxygen. There will be oxygen, but oxygen will be in the form of some fixed oxygen like sulfate, nitrate. So if bacteria will, this biomass will start consuming that oxygen, it will create a anaerobic condition. Okay, anaerobic condition, yes. So we are providing oxygen, so that free oxygen air, so that free oxygen can be available, and aerobic condition is maintained in the system. Because you see, remember, this is a, and what is the main role of anaerobic condition? Anaerobic condition results in fuel anaerobic condition has started to release some gases which make surrounding very foul, means it has started to generate some foul gas which is very in bad smell. Okay, so the trickling filters are indeed known for their ability to handle soak loading effectively due to larger surface area. Remember how big this surface area is there, and everywhere this is fitted, so there is a large surface area. So hence it can be a stand a certain kind of load. Okay, also the tricking filters typically involve simpler operation compared to the certain other wastewater treatment such as activated sludge process. In trickling filter system, water flow over the bed of media such as rock, plastic, and other material where microbial growth occurs. This operation mainly involves monitoring flow rates, periodic media cleaning or replacement, and ensure proper distribution of wastewater over the media surface. So remember what happened, that in suspended water was everywhere. Just ignore what I'm right now saying. So there should be a proper. It should not be such that some media is getting too much of wastewater and some media is getting very little water. So this will affect the overall efficiency of our trickling filter. Hence the correct option is A and D. Okay. The question, answer of this question is A and D. Nitrogen removal efficiency is very high. No, actually nitrogen here just only carbon which is present in the form of organic, which is present in organic matter will be removed. There is no odor and fly nuisance. Remember, we are providing some air still, but microbes are there, so there will be some kind of uh, uh, odor or fly means some kind of insects will be there in that particular area. Okay, so the correct options are A and D. Okay, so again this is a question of these three things: correct sequence of formation of following compounds during the chlorination of water in which ammonia is present. So we all know that first monochloroamine, then dichloroamine, then trichloroamine. Okay, so the sorry, the correct option is B, that is NH2Cl, then NHCl2, then NCl3, and addition of this is, remember whenever you are writing this ammonium reaction with chlorine, try to write these two equation also, because these two equations just show that how this ammonium is coming, because everywhere we are saying ammonia, 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 but we, when we are writing reaction, we are writing with the help of ammonium. And you know that pk is 9.5. So if we want to write in terms of this terms of equilibrium constant, it will be sorry for this handwriting, because I am writing using keypad. So it will be in the form of this equal to concentration of mm, uh, give me some time, NH3, then concentration of H plus divided by ammonium concentration, NH. So now what will happen, that now imagine a pH which is less than 9.5. So if the pH say pH is 7, so the H plus concentration will be how much? 10 ki power minus 7. 10 ki power minus 7. So if you put 10 ki power minus 7 here, it will go this side and it will be less than 0, less than 1. It will, sorry, it will be less than, it will be 10 ki power minus 2, means the concentration of this ammonium is high and this is low. So hence that's why when we are writing, so generally what happened that um, uh, pH of the system, pH of the water is around 7 only, 7, 8, 9, maximum 9. So what will happen that at the most of the time this ammonia is dominant species in the system. So that's why we are writing reaction with this ammonium. Okay. So I hope everyone is clear with this concept of log CPH curve. If you are not, no problem. So there is something called log CPH curve, so that helps us to recognize at what pH which a species is dominant. Okay, so this is pH. So this was your pK value. This is 9.5 pH. Okay, 9.5. So what will happen that till before this point ammonia will be dominant. Okay, and what will happen that sorry, this point will be matching. Okay, now this point is, remember, this is matching here at 9.5, the concentration of this and this will be okay. So this is your ammonia NH3, I'm sorry, NH3, that is ammonia, and this is your ammonium. Okay, NH4 plus. So what will happen that you can see that before pH this 9.5 pH this ammonium is dominant, and after this 9.55 this ammonia is dominant. Either you can draw log CpH, or either you can interfere with the help of this equation. So when we are doing some kind of research, we don't want to, because this is a random analysis, like we are assuming some pH. But when we are doing some experimental work, when you are doing some kind of research, we used to plot log cph curve. This is log cph curve. So that log cph curve is helps to identify the dominant species at a particular pH. So if for a for any system, you can just search miss we know that there is carbonate, or you can for any acid you can just search for this log cph curve. And from the log cph, you can just by seeing log cph curve, you can say that, say for particular pH 5, which of the species is very dominant. When I am saying a species, this ammonia is, there are two species. This is ammonium and ammonia. Ammonium and ammonia. So whenever saying, suppose you have carbonate in the system, so there are total three different form of carbonate. That is CO3 minus carbonate, then bicarbonate, and then carbonate aqueous. I hope you are getting it. What you are getting what I am saying it. So if you search for the log cph of this carbonate, so you will be also getting some kind of curve, and someone will ask that what is the at 7 pH, out of these three carbonate form, which of form will be very dominant. So by looking at the graph, you can say, or you can also you can theoretically can also answer this question. Okay, I hope miss. And remember, when you miss, you can plot, miss, you can generate, you can generate these you can generate the equation of this curve mathematically with, means there are some methods. And if you are interested in this thing, this in log cph, I will ask you, there is one book known as Benjamin book. I will show you at the end of the lecture, so you can refer that book, and from there you can learn how these equation are being generated and how this curve is being generated. Okay, water chemistry by Benjamin. Just if I am not able to show you, just remind me, I will show you. Okay, so the another question is, which of the following are not attached growth, or in other words, they are asking that which of the following is suspended growth. So there is trickling filter. So this is attached growth. So this won't be my answer. This is MBBR. I will show you what is MBR. This is SBR. I will also show you what it is. Then there is MBR. Then RBC, and there is activated sludge process. So I think we have discussed about this, and this activated sludge is not a chat. This will be our answer for sure. But there are other some biological reactor which is present in the system, which is present in the system that help in the secondary treatment. Okay, so I will be discussing it one by one. So this, remember, a treatment filter is a biological treatment that is used a bed of rocks, plastic media, or other material to support the growth of microorganism. So this is a kind of attached growth. Okay, MBR stand for mixed bed biofilm reactor. Remember, mixed bed biofilm reactor. It is a biological wastewater treatment process that utilizes suspended growth with a plastic media to support the growth of microorganism. Remember, this is also this is also a kind of suspended growth. Sorry, this is a kind of suspended growth, means not a attached growth. Okay, now. So I will show the picture of this MBR also. Okay, so this will be our one of the answer, BF. Okay, the Second is SBR, which explain sequencing. Actually, it is sequential batch reactor. No, sequencing batch reactor. Huh. It is a type of wastewater treatment that involves filling a reactor tank with wastewater, allowing biological treatment occur and discharging the treatment effluent in the sequential manner. Actually, it will be, you can somewhere you can also see sequential batch reactor also. Okay, now both term is correct. Okay, but in more frequent way, MBR is not growth. MBR, just MBR. MBBR. Let me just see. So this is a picture of MBR. So yeah, they are using some kind of media in the system. You can see media is there. So this is a kind of attached. This is a attached thing. Okay, so I think. Oh, sorry. My mistake. I misread the thing. So this won't be. This uses a plastic thing. Sorry. Sorry for plastic media to support the growth of microorganisms. That's why this is a attached growth system. So this won't be. So this is not my answer. This is also not my answer. And the third option is SPR. That is So it is a reactor. Here what will happen that we are allowing biological. Here we use a tank, and in that tank we allow bacteria. Thank you for the correcting me. I think your name is Usa. So thank you for correcting that thing. And sorry, mm, sorry that I just misunderstood. I misread the things. So this will be our answer. Okay. MBR stands for membrane bioreactor. It is a biological method process that combines biological treatment with membrane filtration to separate the treated effluent. Remember, this is a separate thing. Uh, we use membrane to remove organic matter from this system. So this is also not any kind of growth system. Also, okay. So this will be this is not kind of any attached system. So the particle will be suspended here, or it will be separated in the different form. So this is also my answer, that is MBR. And the third option is RBC, that is rotating biological reactor. It is a biological wastewater treatment process that uses a series of rotating discs that supports the growth of microorganisms. So it is a kind of attached growth. So there will be a rotating disc. I will show you the pictures where where the microorganism grow. Okay, and we all know this ASP, activated sludge process. See, remember I have already shown the picture of this trickling filter. So this is a mixed bed biofilm. So what will happen that this is similar kind of this trickling filter only, but in the trickling filter what we are using, that we are using a sprinkler and all this thing. But in this case we are not using any kind of a sprinkler. In water, wastewater will be coming and will be going directly in the tank, and after that it will be going to this secondary sedimentation tank. Okay, so there will be a media like plastic media, as I have said earlier, and particles will grow on these things. Particle will grow over this thing, and the microbes will particle will grow, microorganism will grow on those plastic media, and the water containing microorganism will come here, and it will be degraded by the those microbes, and after that it will go to this clarifier or the tank. Okay, so this is sequential batch reactor. So remember, I am using both terms are equal, but I think I will suggest you to use sequential batch reactor in. So there are total five phases. So this is one tank. Water will come here, it will react with some aeration will be done, and microbe will grow there. And after that, what will happen, that microbe will settle down, the water will be drawn, and again that reactor will be again ready for another set of batch reactors. So that's why it is known as sequential means one after another. Okay. Another is this biological rotating biological contractor or disc. So see, different kind of rotating disc are there, and that will support the growth of some kind of microorganism in the system. Okay. So inflow will be from this direction and outflow will be from this direction. So this is very advanced. Membrane bioreactors are very advanced things. They are generally not used in India. There are some places which uses very advanced treatment method because this is very costly. So they are using some kind of, so remember, you can, yeah, you can interpret from this diagram that water is coming, there will be a filtration mode, and they are applying some kind of external pressure and all this thing, and that will help in the removal of my organic matter from the system. Okay. So this is very costly thing. So this is, I think, I don't remember in India where this is substituted, but this is generally used in very developed country. In India also there are some society that treat their own wastewater, use this kind of uh, membrane bioreactors. Okay. So this but overall the summary is that they won't be requiring any kind of attached growth, it is suspended. Okay. So this is activated stress process, which I have already discussed many times. There are several questions uh, based on these things. Okay. Hmm. So this is just to show picture how this, I hope, this is aeration tank, then it will go through the sedimentation this is flow diagram, and this is these are the real picture. So remember, this in sedimentation tank, what happened, that after all the microbes which is there has been decomposed, so what will happen, that it will settle down. After some time, all the microbes, microbes, dead microbes, remember, whenever you are talking about this activated loss, try to imagine this curve. Okay. So this is like this is your lag phase where microbes will, then this is growth phase, then this is stationary phase, then this is indigenous phase, and finally this is zone is finally no growth phase, or I don't remember the exact term. So after that, after this process, this water is being collected. So remember, in 1 liter initially, just remember, let me check. Initially it is around 1 liter. So obviously volume will be constant, but you can see that initially all the suspended solid was all the my organic degraded microorganism, degraded microorganism, degraded organic matter and microorganism are present throughout the system. With time it will settle, and after 2 hours, means it is only 1 liter. So I think it take around 1 hour to settle down this for complete settlement. So now you can imagine this one around its it contains water in like in very high amount. So how much time is required for all this thing. Okay. So this was just to show a clear image of all this thing, all the hmm, all those things. So the the question was, which of the following is not an attached growth process? The answer is C, D, F. C, D, F. Till now, if you have any kind of doubt, you can ask. So I will be going. You can ask me. You can interrupt at any time. Okay. Select the correct statements. Uh, Select the correct statements regarding the disinfection and its method. Okay. Again, we have this thing. disinfection. So this is a pure theoretical question. You can just by seeing the question you can answer the questions, but still I will be going via one by one option. Please share few solve. Let me see the where to see the chats. Please share a few sort free and combine. Actually, right now, though, I haven't prepared it, but I will share you some reference book where you can miss, where you can just go and the best way to the solve this free and combine. I will be asking you to go to this previous gate year questions, because whatever questions which is there in the system or in books are okay. I can do that. So please share your email ID. Yes, I will just share you. I will share you via that some important question, and I will be also sharing some of the lectures which I have done during my MTech course, sorry, PhD courses. So please share your email ID. I will share it via email. Hmm. So I will be continuing with this thing. Sorry that I don't have the questions right now, but I will surely share it via email ID. So the ozone, the question is the select the correct statement regarding the disinfection and its method. The options are ozone forms residual in disinfection process. So you can directly say, oh, this is incorrect. Ozone does not leave any kind of residue in the system. Reason I will explain. I will be explaining each and every option one by one. The disinfection efficiency of chlorine decreases by increasing the contact time. Um, this is also incorrect because increase. Just we will see the turbidity affect the UV removal efficiency. Ozone requires relatively shorter contact times than the chlorination. Okay, so I will be discussing each and every option one by one. Ozone forms residual in the disinfection. This was my first option. This statement is incorrect, as I have already said. Why? Unlike chlorine, ozone does not form a stable residue. The reason for this residue, because they are this ozone is chlorine is reacting with some of the ammonia and they are forming some kind of residue. Okay, so unlike chlorine, ozone is O3. Remember that simple O3 which we know. It's not like something special. Ozone does not form any stable residue in the water, and after the disinfection process, ozone decomposes rapidly, leaving behind oxygen as their only residual byproduct. Now, what will happen that ozone will oxidize and it will be leaving oxygen behind, and that oxygen will escape in the system. Okay. Therefore, oxygen does not leave residue in the water after disinfection is complete. In contrast, chlorine can leave residuals such as chloramines which continue to provide disinfection as water moves through the distribution system. I hope this is clear to you. Okay, so just simple you can it's instantaneous process. Water is there, it will act on that. That's all, nothing else. And oxygen which will form in will be there. It will escape in the system. Okay. The second option was the disinfection efficiency of chlorine decreases by increasing the contact time. Okay, this statement is incorrect. In fact, disinfection efficiency of chlorine typically increases longer. See, longer the time, longer the efficiency. Okay, if you are disinfecting or if you are treating something, the longer time you invest on that, it will work in efficient way. Now suppose for, because we know that there is something called Chick's law. Okay, I will. There is question number 9 is based on that. So that say that suppose initially some kind of some pathogens was there, and to kill that pathogens there is some time required for that. It's not that it will instantaneously. The longer time you get, the more chlorine, more pathogens will be killed by chlorine. Okay, so this statement is incorrect. The longer time allow the time more chlorine molecules to come in contact with the microorganism in the water, increasing the likelihood of the reaction and effectively disinfecting the water. Therefore, longer contact times are often desirable for chlorine based disinfection process to ensure through disinfection of water. Okay, I hope this is clear to you. The turbidity affect the UV removal efficiency. Yes, this is correct, because see, remember this was your disinfection. This is your uh, pathogen. Remember, pathogens are invisible to eyes, but still, now you are striking UV rays. And now remember that turbidities happen due to some colloidal particle present in the some, not colloidal, means some particles present in the system. So now this the UV rays coming to the hair, it will, instead of killing hair, it will just get diffracted in this direction. Okay, so that's why it will decrease the efficiency of the disinfection. The turbidity in water can interfere with the UV disinfection by scattering and absorbing UV lights, reducing its effectiveness. Thus, turbidity affects the UV removal efficiency. Okay. Ozone requires relatively shorter contact time than chlorination. Obviously, this is correct, because it can, at once time you provide oxygen, it will kill all these things. That's all. It does not require some reaction to happen, then it will form. Oxygen required typically require a certain time compared to the chlorination of effective disinfection due to high reactivity and its oxidizing. Remember, this O3 is very reactive and very oxidizing in nature. Okay, so it will at it will instantaneously kill all the macros present in the system. This shorter contact time contributes to inefficiency in treating water one. But see, in spite of these things, we generally do not use ozone. The reason is that first, it is very cost effective, and it is not future. It won't be protecting from future contamination. Okay. Then the correct option are C and D. Okay. I hope this is clear to you. The last question which I was saying that, see, the disinfection solution content initially this was, remember this coliform. Okay, CFU stand for CFU full form coliform. What is the full form of CFU? Just let me check once. I'm just not remembering it. CFU full form. Colony forming unit. Okay, colony forming unit. Okay, CFU stand for colony forming unit. So how this unit comes, I will ask you to go to this first year second lecture, or you can go to any books where they are discussing about this thing. What do we call, coliform bacteria. So what happened that, I hope everyone is aware of this coliform concept. So generally what happened that in my water there are several kind of pathogens, bacteria, viruses. So we cannot individually measure them. So what happened that we have generated one such thing called indicator microorganism. So what happened that if that indicator microorganism is present in the system, then we will say that the water is water contains some pathogens which is harmful to humans, yeah, harmful to for drinking. And if that indicator actually there is some limit. Okay, that you can see in the IS code, that is 10500. So if that indicator if the if a water containing number of indicated pathogen is higher than what is specified in the code, then that water is very harmful to you. So that is measured in this CFU per ml only thing. Okay now. So what happened that this what now we know that initially there was some bacteria in the system. Initially there was some bacteria in the system, and with time we are adding chlorine, so the number of bacteria, the number of microorganisms present in the system will decrease. So you can see this is following this trend, and we know that this trend is followed when the order of reaction is first. Actually I'm assuming one thing, you have attended my previous lecture where I have discussed about this mm, kinetics. So what happened that there are several order of kinetics: zero order, first order, second order. So zero order means this is directly increasing with time. Then second order is first order is this kind of decrease, yeah, this kind of increase. Okay. And then there is second kind of order. So what happened that we already know that this death of microorganism is due, as per this is universally accepted thing, that decrease in the population of the microbes is according to the first order reaction. But there was one some scientist named as Chicks. He proposed one Chicks law, which say that at any time the number of microorganism will be proportional to the concentration of microorganism present at that time. So so this is equation is given by dn by dt is directly proportional to first order, or first order, that is n की power 1. Okay. Directly proportional to the concentration, microorganism concentration present at that time. So where n is the microorganism concentration at time t, and this, see, remember, this decrease is happening at some rate. So that rate is known as degradation constant or inactivation rate constant. At what rate that is being in that pathogens, that microbes are being inactive. Okay. So, and remember, initially there was some concentration at t is equal to 0, t is equal to, this is t is equal to 0. So at this time what will happen that it will microorganism will be at its highest concentration, that is n naught. Okay. So at t time it will be n naught. So, and sorry, this will be not l naught, this will be n naught. Okay. Correct. Let me correct now. Hmm. So this will be this will be n naught. Okay. So will be integrating this thing with the help of with respect to time and n naught, and you can see we'll be finally arriving at this equation, that this n is equal to n naught e minus ln t. So it will be decreasing at in this in exponential way. Okay. So the question is like, you have given initial concentration, final concentration, rate constant, and you have to find t. Okay. So for our question, n is equal to 0 point this thing, n naught is equal to this thing, and you can. So remember, this equation is, when someone asks you what is this Chick's law, what is Chick's equation. Okay na. So you will be reporting this equation. Okay. And if someone is what is Chick's law, you will be stating that statement, that concentration of any organism, the rate of change of any decay in the concentration of organism is proportional to the concentration at that time. Okay na. So this is Chick's equation, and this is Chick's law. Okay. Remember both. Yeah, just understand, listen to the question carefully what they are asking. Okay. So we'll be putting all this value, and we will be getting this. You can see that to decrease the concentration from 2.5 to miss this much, um, they are requiring 207 days. Okay, so it is around how much hour, sorry, hour. So you can imagine how much time it is required to kill all the microorganism. Okay, so remember this was a simple that they currently there are total three chicks law. This was first law. Okay, now this was first equation. Then there is second equation, second law, that is modified chicks law. So in that equation, what will happen? In that equation, the equation will be same, but instead of this n naught n naught e minus kt, a term, they say that it's not directly proportional to the time. Here what we are saying that e की power minus kt, they are putting some constant. Okay, m. Okay, and m can be less than equal to 1 or greater than equal to 1, or can be 1. If it is 1, then it is normal Chick's law, and if it is not if it is not m, it is less than 1 or greater than 1, then it is known as modified, what do we call, modified Chick's law. Okay, this equation was modified. Hmm. And the third equation, the first, second, and third equation which is there, see, we are we are writing this equation just to know the microorganism concentration. Okay, na, that how the microorganism concentration with time means, we are adding some chlorine at some rate. This chlorine, this there, there will be decline in the population of pathogens now. So how these pathogens, yeah, how is occurring in the system, it is showing that thing. Okay, so in there is third law, that is Chicks and Watson law. Okay, third law, which do not talk about the concentration. Till now we are we are discussing about the concentration of microorganism, but we are adding some chemicals also there. So there's some the how this chlorine which we are adding in the system is degrading with time, or because with time that has to be also calculated. So it is said that Chicks Watson, I'm not writing because writing will be very difficult, so you can note down Chicks Watson law. So that law say that C1, that is concentration at T time. I will be just writing this, N1 is equal to C2, C2 N2. Okay, so what happened that you have added at t equal to at t at some time t, you know the concentration of chlorine, and you will be knowing the coefficient of this n1. So you can calculate that after what time, and if this coefficient is being given to you, then you can calculate what will the concentration of that chemical that you have added after time t. So this is known as Chicks Watson law. So again, I don't have numerical on this law, but generally in gate, I'm just miss. I everyone know what this gate exam. Please, miss. I'm continuously saying gate examination. So, are you aware of this gate exam? Please, someone answer. Yes. So, I actually see. Generally, I should not highlight this examination thing because I am here for discussion. But why I'm asking, because that question is that exam fully based on numerical thing, because they ask too much numericals and all these things. So I'm asking you to go to the watch those, because to learn these things, because you have already learned theory things, but you have to do numericals. Why numericals? Because in real world you have to design something, And if you are not knowing the to design, you have to do some calculations, do some assumptions. So if you are not doing that those things, you won't be able to relate those things in a real world application. So that's why it is crucial to know this theory part thing also and numerical part also. Okay. So, I think in 2020 civil engineering, 2020 and 19, there was a question related. They asked a lot of question on this Chicks and Watson method. So, either they will be giving you out of 16, they will give you five things. Or remember, this T can be in the form of velocity also. So now what the question can be in this form, that suppose this is a river, and it is flowing with the V flow. uh, at some time you have inserted this, you have applied some chemicals at t barabar t1 at 5 hour, and this is following. So what will be the concentration after 5 kilometer? So this can be a question can be on this type also. So you know the velocity, you know the distance, you can find out the time. Initial time was 5 hours, initial concentration will be given to you. You have to find C2. Or they can ask you that after at 5 kilometer concentration was by initially x, it was x, after 5 kilometer it was by. So find out the concentration after how much time. Miss, you, I think I have shared my, okay. Okay, I will share you. Please don't worry. Okay. So hope this equation is you are able to relate this equation. Relate this equation. Okay. So before going to the final question, that is 10th question. This is question 10th question is related to pH only. So before answering pH things, I want to discuss how miss I think this is basic thing, but I still miss people make mistake in the calculation of the pH. If you are a person who is graduating, even from them also, if you ask, if you just give a complex system, yeah, given some, ask them that this is a system containing this salt, find the pH of the system, he or she might face some problem, because either they are some using some conventional method, or either they are I don't know. But people, it has been observed that in interview the basic question which is being asked, especially in this IIT Kanpur, if you are appearing for this environmental engineering exam, PhD interview, a master interview, or in environmental department, there are some professor, I think every professor in the water who works on water, the first question what he will ask, what is pH, and they will give you some, they will ask you to find the pH of the system. And it has been observed that out of, suppose there are 20 people giving interview for the masters or PhD, out of 50% of them make mistake. Either they everyone know the definition of the pH, but someone started say there is a particular pH definition of pH, but people will just, please share question, which question, this pH question. I will share you, but please, miss, let me explain some concept, because that is last question, and I have miss. I have today's lecture. I have focused on this pH portion, because I will be. I can share you, miss. See, I am sharing you, but you can take the screenshot. But actually, I have prepared my own question to own question. But last question was this was your last question, that pK of this HA is a weak acid, concentration of this A minus is this much, then you have to find the concentration of undissociated HA star at the equilibrium edge. So you can take the screenshot, but I will explain, because half an hour is left, and I will, because you can see there are 8 slides. So I will be discussing each and every concept, and I will be discussing the how to calculate the pH of weak acid, a strong acid which is very diluted in dilute, which is very dilute. Okay, so this is my target for today. So if you I hope you have taken on the screenshot of, a screenshot of this question, so you can solve by yourself, or you the see general trend is they will write reaction blah blah blah, and then you can see that I have used some equations, and from the equation I have find out the answer. So how this equation is being generated, I will discuss you. If you know this thing, it's okay, you can listen it or you can solve on your own. Please confirm, have you taken note down the question? If yes, I will be start discussing. I hope you have noted down the question. So all I have said that you should know the concept of this pH. So see, I will basics. This is basic definition. And acid is any chemical which, when added to pure water, results in pH decrease in pH. So a pure water will have a pH of 7. So if you add acid, its pH will start going below 7. And base is a chemical when added to pure water which has a pH of 7 will increase. So if you add base, the pH will start increasing, that it will be going above 7. Okay, so then this is the concept of a strong acid. And a strong acid when added to water completely dissociate, that this HCl will completely dissociate in H plus and Cl minus. This H2SO4 will completely dissociate in 2H2 2H plus and SO4 2 minus. Okay, and the strong base is similarly which completely dissociate. Okay, and remember this is our water. Our water generally form H plus and OH minus, and this is water constant, that is 10 to the power minus 14. And remember, I am using this curly bracket. Generally, whenever I am writing some concentration, I will write in this form. Uh, this form. Remember, I will just show you the when I was plotting uh, this diagram, this PK. See, I was using this a square bracket, but here I am using curly bracket because there is a difference. This curly bracket is known as activity. Okay. So they remember, when you present something, this is known as a constant, sorry, concentration, and when you are bracket representing in curly bracket, it is known as activity. Okay, so this kW is known as activity, and this known kW is active, some of the mm, ratio of the reactant product divided by reactant, and the ratio of activity of reactants divided by activity of product divided by activity of reactant. So there is some, and now what is this activity? I will refer you one book. Please go through that book because that this is very important. Okay, so generally what is happened, that for pure solid, yeah, pure liquid, and H2 is a pure liquid, so activity of this pure liquid is 1. So this is my water constant. Remember, I am introducing this one new term, activity. There are chances that many people don't know what is this activity things. Generally in 12th class or in our initial stages of BTech, we just write this water constant is concentration of H plus into concentration of water is equal to concentration of OH minus. But this is wrong. This is not wrong, but actually there are some concept behind why we are saying concentration and why we are saying activity. So if you see some standard book, they will never say concentration. They will always say activity of water, activity of H plus, activity of OH minus. And what is this activity? This activity is, I will just discuss saying that this activity is known as, this activity is given by concentration of that ion, concentration of that species into some activity coefficient. So this gamma is defined as activity coefficient, and then this activity coefficient is calculated by different equation that is known as Debye-Huckel equation, extended Debye-Huckel equation, and Davis equation. So there is a relationship between this gamma and this concentration. Sorry, this gamma is calculated with the help of this equation, and when you know the concentration of your species, you can find out the activity of that species. Okay, but in our cases we will keep this gamma equal to 1, and hence this activity will be equal to the concentration for our discussion. Okay, we have assumed this thing. So, and remember what I was saying, that pH. So if someone asks you the pH of definition, then you will be saying that minus of log of activity of H plus. Remember, I am saying activity. This is a standard minus of logarithm activity, not concentration. But for our discussion, we have said that activity is equal to concentration. That's why we are saying this thing, minus of log 10 of H plus. Okay, but the real definition, this is if someone is saying blah blah blah, they are all wrong. Means all wrong. The definition of pH is simple: negative of logarithm of H plus activity. That's it. If you say this thing, the person who is taking your interview will be satisfied with your answer. They will know that you are not making any kind of a story, because people make when they start, someone asks the what is the pH of definition, sorry, definition of pH, they will start making some kind of a story. But you should not make a story. You are giving some interview at some, they are expecting things from you, particular answer, so you will be answering it minus of log 10 of H plus concentration or activity. It's better to say activity only, but if you are not aware of this activity, no problem, people will understand. Okay, but when you, at some point, if you are at a higher level, you are a PhD student, then people expect from you that you have to say activity of H plus. Okay, so the first question is H plus. The answer of this question is 3, because we know this we know this thing minus H plus, and from this thing, from this 10 to the power minus 3 molar HCl, we will be giving 10 to the power minus 3 molar. This HCl will dissociate completely in the form of H plus, uh, H plus and Cl minus. Okay, so this will be giving 10 to the power minus 3 molar HCl. Remember, this is HCl. Okay, this will be giving 10 to the power 3 HCl and H plus, and 10 to the power minus 3 molar Cl. And we know that definition of pH is minus of logarithm of H plus concentration or activity of H plus. So pH will be 3. So I will be, this was direct question. So still we know that the one relationship, that is H plus OH minus is equal to 10 to the power minus 14 Cl minus is concentration. So remember, we are adding in a system where we are, H2O is already there, and we are adding externally H plus HCl minus. So in that system, what species are present? One is H plus is present, H plus is present, and another is OH minus is present, OH minus is present, and the third thing which we have introduced is Cl minus. So remember this. So what happened, that when the system will be in equilibrium, all the negative charges will be equal to the positive charges. I hope this statement is very clear to you. So B, for calculation of pH, we do not rely on any equation. We rely on the concept of charge balance. We know that when we are adding H plus Cl minus in the system, when we are adding Cl minus the system, H plus is already there, OH minus is already there. So sum of the positive charge will be equal to the sum of the negative charge. So I will be using this concept. So I will be using the concept of charge balance. This H plus will be equal to OH minus. So what are the positive charges? Only H plus is there. And what are the negative charges? OH minus and Cl minus is there. So, and my aim is to find this Cl minus. So the H plus, because pH definition is given by this thing, H plus minus log H plus. So somehow if I find out my H plus concentration, I can answer this thing, pH. I can answer report my pH. So H plus will be remain as it is, and now we know the relationship between H plus and OH minus. So from this equation, I can write OH minus is equal to 10 to the power minus 14 divided by H plus, and Cl minus I already know 10 to the power minus 3. So this will be your final. This will be your second equation. Miss after this, and I will be taking this H plus on this side and H plus on this side. Okay, so it will form this quadratic equation, that is H plus square minus H plus 10 to the power minus 3 minus 10 to the power minus 14. And if you solve this quadratic equation, how can you solve this quadratic equation? You can use this ABC rule, that is under root B square minus 4AC divided by blah blah blah. Or or as a BTech student, everyone is supposed to carry one calculator in your examination. Even in GATE examination, calculator is being given to you. So you can best method is to use, see, which I don't know. I also use to solve this thing. I use calculator only. So you can put all the value here. You can solve this. H square will H plus concentration is this, and your pH will be 3, which I have already said. So here in this equation also you can ignore this thing, because you know that this H what this thing, 10 to power minus 3 very high compared to 10 to power minus 14. So this can be 0. So there is no need to solve this equation. You can directly report your answer as H square is equal to 10 to power minus 3. Okay. The second question is find the pH of 10 to power minus 8 molar H2SO4. Okay. So remember again, same thing, H plus and OH minus is 10 to power minus 14, and SO4 2 minus is 10 to power minus 8 molar, because when this will dissociate, it will give 2 molar of H plus and 1 molar. Or now in remember, in pure water we have 10 to power minus 7 H plus, and you are in that water you are adding this 10 to power minus 8 molar H plus. So this cannot be neglected. So you have to do assumption, but I will neglect those assumption. I will just work on my concept, that is of charge balance. So in my system, H plus is there, OH minus is there, and sulfate is there. So I will be applying this charge balance. So one positive charge is what is there, this H plus is there, OH minus is there, and now remember this two negative charge is there. That's why I have multiplied by 2, because this singly handle, this is providing one negatively charge, and this is providing two negative charge. So that's why I am applying two negative. Remember, we are balancing charge. That's why all the positive charge will be equal to all the negative charges. Okay. So again, this OH minus will be substituted by 10 to the power minus 14 divided by H plus, and concentration of this HO4 is 2 into 10 to the power minus 8. Okay. Again, I will be rearranging the equation, and the final equation will be in this form. Here I cannot neglect this 10 to the power minus 14, because this 10 to the power minus 8 is in a significant range, because H plus will be also in that range only. Okay. So if you solve this, for solving this equation you have to take the help of calculator, and after solving this H plus, you will be getting H plus is equal to 1.05 into 10 to the power minus 5, and if you take the log, it will be your pH will be 6.97. I hope this, see, with the help of this, in many book in 12th class, how we used to do this thing. We used to write the equation, then we used to say them alpha beta, alpha 1 alpha 2 blah blah blah. I hope you have remember, but This is a very simple concept that we have to use the concept of charge balance. All the positive charge is equal to all the negative charges. Okay. So from the here we can say that the pH of the system is 6.97. Is this clear to you? I am going fast because I am assuming that many of things you have already know. Now there is concept of this weak acid. Weak acid when added to the water incompletely dissociate. So remember, it is incompletely dissociated in the system. So when acetic acid is added in water, it will give some H plus. It will also give some CH3 COOH minus. But some of the CH3 COOH which I have added will remain in its original form, and that is known as CH3 COOH a star. Where I am giving, because this I have added CH3 COO in my water. Some of the has been dissociated and some of was in remain in still in original form. So that is, I am donating by CH3OH minus a star. And see, remember this pK value is to just donate that after this pH 4.8, uh, after this pH 4.8, the dominant species will be CH3O minus. This is, and before pH before 4.8, this star here, the star one will be dominant. I'm just donating a star, and here I am saying that A minus. Okay, acetic acid, here I am saying A minus will be dominant. I hope this is clear to you. Okay. And now imagine, so the question is find the pH of 10 to the power minus 3 molar CH3 stable OH solution. Okay. So again in this system what will happen that H plus is there, OH minus is there, and total CH3 stable OH which is there will be, I am donating it is in the form of Ca, that is 10 to the power minus 3 molar, and that some of them has dissociated in the form of CH3 double O minus, and someone is some part of the CH3 is in still in its original form, then that is known as CH3 double O star, CH3 double OH star. Okay. Now you remember in your system what is there, H plus is there, OH minus is there, and this charge is there, and this has no charge. Okay. So I will be applying charge balance. The charge balance will be H plus CSOH minus and this acetic acid. Okay. The problem is that we don't know how much of this 10 to the power minus 3 part has been converted to this and how much is in this form. Okay. So I will be trying and my final aim is to convert this equation in the form of H plus. So we know that this OH minus can be converted into H in the form of H plus with the help of this equation. But somehow if I convert this thing in the form of H plus, then I can substitute that equation here, and I can able to find the value of H plus. So first relationship is this thing which we know that Ca is equal to CH3 O minus plus CH3 O star, and remember this CH3 O star can be written as H plus CH3 O minus divided by Ka. So I have put it that thing. So Ca will be CH3 O minus plus this equation, and if I take out this CH3 double O minus common, it will be 1 plus H plus divided by K, and this can be reformulated in K Ca divided by Ka plus H plus. Then this is constant. Remember this H plus for a particular pH, this H is constant. Then not constant means for a particular pH this is constant, and then that is termed as alpha 1, and this then the concentration of CH3 double OH minus is given by alpha 1 into Ca. Okay. So this so what I can do that I can substitute this equation at this in this equation, then my final equation will be this thing, and I will be putting all the value here, and if you rearrange this question, this will be a cubic equation, and you can solve this cubic equation with the help of calculator. I hope this is clear to you. This is but just putting equation. So if you solve the quadratic equation, you will be getting H plus concentration is equal to 1.2 20223 into 10 to the power minus 4, and pH of the system will be 3.92. I hope this is clear to you what I have done. And remember, I can by putting the value of this CH3COOH minus, I can find the concentration of CH3COO minus. Okay, and the second part is that I have to find how much there might be a question that how much was undissociated form. So you know the total value 10 to the power minus 3, and you have already calculated this thing, CH3COO minus concentration. So you can subtract from that, or either you can you can find out the equation for this thing also, CH3COO minus also. Okay now, so that will be equation will be given by H plus divided by Ka plus H plus, and this is known as alpha naught. Remember, this was alpha, this was 1, this was 1. Okay, and this one will be alpha naught, and this is already Ca. So you can either find the value of undissociated form in any form, either by this equation or this equation. So people, you, I think I will ask you to solve, formulate this equation um, by yourself at least once a time. And remember, actually there is no need to remember, you can anytime you can generate this equation. But suppose if you are sitting for some competitive exam, you should remember this equation. And there is no miss such things. You know that for a big acid there will be Ka and there will be Ca. So how much charge, so you can, for um, ions it will be Ka Ca divided by Ka plus H plus, and for non, for I I hope you have understood thing. Okay. So similarly, another question is find the pH of 10 to the power minus 3 H2O solution. So, and remember, again this H2O will be, first it will deprotonate one acid, and it will form Ha minus, eraser, either it will for Ha minus, again this Ha minus, again this will donate one H plus, and it will form A2 minus. So can you imagine, miss, you can draw the log CpH curve of this equation also. So this will be 6 pH 6.3, this will be pH 10.3. So before pH 6.3 what will happen, that this will be dominant, so it will be like this. After pH 6.3 this will be this one will be dominant, so it will look like this. Okay, and till after this point what will happen, that this A2 minus will be dominant, so it will look like this. Okay, so this is for H2A, this is for H2A, this one is for this thing, and this one is for this thing. Okay, I hope you have. So someone, if some, and this is pH 6.3, this is so if someone asks at pH 7 which one will be dominant, so you can clearly say C at the log CpH, and you can say that this Ha minus will be most dominant. Okay, I hope this is clear to you. So again I will be solving this charge balance. This will be total Ca will be, sorry, the question is 10 to the power minus 5, not 10 to the power minus 3. Okay, again this will be your this what will happen, that I have added H2A, someone will and this will be a star, I just forget to write, this will be a star. Okay, a star, Ha minus and A minus, that will be 10 to the minus 3. I know this thing. And similarly, similar to that equation alpha naught alpha 1, here you can also calculate this alpha 1 alpha naught alpha 1 with the help of these equation. Alpha 1 alpha naught will be, I am not solving this, I am just directly giving you. But if you are serious about this environmental engineering thing, I will request you to derive all these equation, alpha naught alpha 1 alpha 2. Okay, so H plus square k1 k2, alpha naught will be given by H plus square h1 star h1 square k1 h1 h plus k1 k2. Similarly this thing, and we know that in the system this is present, this one is present, H plus is present, and OH minus is present. So charge balance will be H plus, OH minus, HA minus plus 2A 2 minus. Okay, I will be H plus B will be substituting 10 to the power minus 14 divided by H plus HA minus. I will be alpha 1 into Ca. Alpha 1 is this one, and A2 minus I will be alpha 2, that is this thing, and Ca is 10 to the power minus 4. See, H plus blah blah, this thing blah blah, no sorry, not here blah blah, H plus kw by H plus alpha 1 Ca plus 2 alpha 2 Ca. I will be using, this will be a fourth fourth order equation. So this won't be solved by what do we call, calculator. So you have to use Excel, yeah, any kind of MATLAB or Python equation, you can solve this. After solving this, you will be know that pH will be equal to 5.3. Remember, this is 5. Okay, 5.69. The concentration of each species can be find by putting value here. Okay, so the final question was, see, remember, now this is very simple question if you remember that formula. The pH of the solution of adding acid is 4.8. So H plus concentration is given to you. The deprotonated form, that is A minus is 10 to the power minus 3. Then you have to find the HA star. So you know that A minus is given by alpha 1 Ca, and HA star is given by alpha naught Ca. So the HA is a weak acid, pH 4.8. So H plus is this one. So A minus is given by alpha naught Ca, that is this thing. HA star is given by alpha 1 Ca. So from this, you have given the concentration of A minus, that is 10 to the power minus 32. So I will be putting the value of K minus. From here I will be finding the Ca value, that how much Ca I have added. Once I know this Ca, I will be put this Ca in this thing. Ca is equal to, now you have two options. Either you can put you have to find Ha plus, you can directly put it here. You know H plus Ka, and you can find the concentration of Ha star. Okay, so so or either you can subtract from here 7.03 into 10 to the power minus 4, plus the concentration of this HA star 10 to the power minus 3. From there you can find the concentration of HA star, or you can put the value, or either you can use this equation to solve to find the concentration of HA star. I hope this is clear to you. If you have any doubt, you can ask, because time is up. It's called not up, miss. I can go. If you have any kind of doubt, you can please ask. Where is the uh, oh, okay, I will share you this thing. Hmm. Okay, so Priyanka Trivedi, if you have any kind of doubt, you can ask, or I will be ending this meeting. Okay, so Tata.